Welcome to Lesson 2 on chemical changes. In today's lesson, we're going to look at the reactivity series of metals. Make sure you've watched Lesson 1 on metal oxides, reduction and oxidation before moving on to this content. Imagine that someone gave you samples of each of these different metals shown here, and then they asked you to rank them in order of most reactive to least reactive. I wonder how successful you'd be just by looking at the metals. After all, they're all shiny metals with only slight variations in tone, so therefore by just looking at them it would be very difficult to determine how reactive they are. So instead we're going to talk today about how we could use experiments to determine an order of reactivity. Let's begin by looking at the alkali metals, which are found in group 1 of the periodic table. The alkali metals are shown here on group 1. I've highlighted them in purple. The alkali metals include the most reactive metals that we find in the reactivity series. And this is because they react readily with water at room temperature to form alkaline solutions. Today we're only going to look at the reactions of lithium, sodium and potassium because these are the 3 alkali metals that we have available in schools as they're safe to use. Lithium reacts with water, as you can see here. And when we drop the piece of lithium into the water, we notice that it floats. It floats because it's less dense than the water. I'll show that animation again because there were some other observations that we can see. Not only does it float, but it effervesces. Effervescence means to give off a gas, and the gas being given off here was hydrogen. You may have also noticed that the piece of lithium dissolved as it reacted. Let's try to describe this using word and symbol equations. Let's start with the word equation. We began by reacting lithium with water, and it formed lithium hydroxide and hydrogen gas. Lithium has the symbol Li, and it's a solid. We need to use a 2 to balance the overall equation. Water is H2O, and it's a liquid. Lithium hydroxide has the formula LiOH and it's aqueous, meaning it's dissolved in water. And the hydrogen has the formula H2 and it's a gas. The lithium hydroxide is the alkaline solution that's formed when the alkali metal reacts with water. It's actually the hydroxide or OH part of it that causes it to be alkaline. Now let's look at the reaction of sodium with water. As I drop the piece of sodium in, again it floats because it's less dense than water. It dissolves into the water as it reacts, and it effervesced hydrogen gas. But you may have also noticed that it burned with a yellow flame. If you were to see this in real life, you would also notice that the sodium would melt as it reacts into a ball. The word equation for this is sodium plus water goes to form sodium hydroxide plus hydrogen gas. And again, the symbol equation is much the same. Sodium is a solid metal reacting with liquid water. Sodium hydroxide's formula is NaOH and the hydrogen is again H2 gas. 2's in front of the sodium, water and sodium hydroxide in order to balance the equation. Finally, let's look at the reaction of potassium with water. It floated on the surface but then exploded with purple flames. It also gave off hydrogen gas and it dissolved as it reacted. We can describe this using a word equation. Potassium plus water goes to form potassium hydroxide plus hydrogen, and again the symbol equation is much the same. K as a solid for potassium, H2O as a liquid for water, KOH for potassium hydroxide this time, and H2 for hydrogen gas. Let's now overall compare all of those different reactions. So, to begin with, we reacted lithium with water. Our observations were as follows. It floated on the surface as it dissolved. There was a medium effervescence, in other words it bubbled a little bit with the hydrogen gas coming off as it reacted. Sodium next. Again it floated on the surface but it dissolved more quickly. It melted into a ball and ignited with a yellow flame. And it had much faster effervescence of hydrogen gas as it reacted. Let's finish off with potassium. It floated on the surface as it dissolved, but it ignited with a purple flame and exploded. and it had the fastest effervescence of hydrogen gas as it reacted. So if we're going to determine a reactivity rank for each of these, I would say that potassium with its explosion and purple flame and fastest effervescence is definitely the most reactive, number 1. Sodium with its yellow flame but slightly slower rate of effervescence will be number 2. And definitely the slowest of all of them was lithium. Let's now take this back to the periodic table and try to describe a trend. What we should find is that reactivity increases as we go down group 1. Potassium is our most reactive, sodium our second most, and lithium our least. So therefore, we can infer that the reactivity is increasing as we go down group 1. So, if we come back to that collection of metals that we started with, we can say potassium is the most reactive, followed by sodium, and then lithium. Next, let's move on to calcium, Ca, which is found here on the periodic table. Now, calcium's not an alkali metal, but it will react with water, albeit with a much slower rate of effervescence of hydrogen gas, so the gas is going to be bubbling off of it much slower. Let's have a look at this reaction. We're going to drop the piece of calcium into a beaker of water. You'll notice this time it sinks. This is because a lump of calcium is more dense than the water that it's being dropped into. You can see the rate of effervescence is much slower, and it took a lot longer for the piece of calcium to dissolve. We can again describe this using an equation. Calcium plus water forms calcium hydroxide, so again an alkaline solution, plus hydrogen gas. Let's describe this using a symbol equation now. Calcium has the symbol Ca. It needs to react with 2 water to form calcium hydroxide. You can see the OH in the formula, and H2 gas. This means that we can rank calcium number 4 in our order of reactivity or reactivity series. Now we're going to draw a line between these first 4 metals which reacted with water at room temperature and the rest of the metals. So we can say that the most reactive metals react readily with water at room temperature. However, this leaves all of these metals over here. Now, some of these metals will react with water at room temperature. However, the rate of reaction is so slow that it's difficult to observe. In other words, there's only going to be a few bubbles coming off of them, and therefore it'll be very difficult to compare all of these if their rate of reaction is so slow. Instead, what we could do is try to react these metals with steam. That's water at a higher temperature. That would increase the rate of reaction to an extent where we could observe any differences between them. The problem with this is that if we reacted them with steam, it would be very difficult to observe the reaction because the steam would get in the way and obscure our vision of any differences in reactivity. When we react these with steam, we find that these 6 metals up here do in fact react with steam. However, it's very difficult to compare the reactions because you can't see past the steam. Instead, what we're going to do is try to react all of these metals here with acid instead. Let's describe a method for comparing the reactivity of different metals by reacting them with acid. To begin with, we're going to place test tubes into a test tube rack. And we're going to fill each test tube with an equal volume of hydrochloric acid using a measuring cylinder. Other acids like sulfuric acid and nitric acid would work as well. We're then going to use a balance to weigh an equal mass of each metal being tested. This is a key control variable to ensure that the mass of metal going into the test tube is the same. Now, some metals come in different formats. In other words, some of them come as powders and others come as lumps or pieces of ribbon. It's very important that for each of the metals we are comparing, we use the same structure of the metal. So we either need to use all the metals as lumps or all the metals as powders. We don't want to mix those up, and this is because it will affect their surface area, which will affect their rate of reaction. We don't want to do that because we only really want to compare the reactivity of each metal. We don't want to compare the reactivity based off of different surface areas or anything like that. We're then going to drop each piece of metal into a test tube at exactly the same time. And then either we can measure the rate by timing how long it takes for each metal to dissolve. The one that dissolves the quickest would have the fastest rate of reaction and therefore would be the most reactive. Or we could try to compare the rate of effervescence, that means bubbling, by counting the number of bubbles given off in 1 minute. Let's now have a look at some mock results that we would get from this experiment. First of all, with copper, gold, silver and platinum, we would find that there were probably no bubbles given off in 1 minute. So therefore, they're never even dissolving. There's no reaction really taking place with these. So by reacting these with acid, it would be very difficult to compare these four. So we're going to exclude those from our reactivity rank for now. But what we can infer from this information is that these four metals are the very lowest on our reactivity series. They're the least reactive. The most reactive of our metals turned out to be magnesium. Magnesium gave off 121 bubbles in 1 minute. Realistically, that would be very difficult to count. It dissolved in 61 seconds. So therefore, its reactivity rank, starting at 5, because we ranked calcium earlier as number 4, is number 5, the most reactive of this set of metals. Next up came aluminium. It gave off 94 bubbles in 1 minute, and it dissolved in 70 seconds. So therefore, this one's going to be ranked number 6. You'll notice the time taken to dissolve was longer, therefore it reacted slower. This is also shown by the fact it gave off less bubbles in 1 minute. You might notice that I've said the aluminium's been sanded here. This is because aluminium normally has an oxide layer on its surface which prevents it reacting with an acid. So it's very important to sand off pieces of aluminium before you want them to react. Next up came zinc. Zinc only gave off 34 bubbles in 1 minute, so fewer bubbles. And it took even longer to dissolve at 184 seconds. Therefore, we're going to rank zinc number 7. Iron came next, only giving off 12 bubbles in 1 minute. It took even longer to dissolve, 482 seconds. We're going to rank this one number 8. Tin came next, only 7 bubbles in 1 minute, and it took 542 seconds to dissolve. Let's rank it number 9. Finally, the slowest of the set was lead, giving off only 4 bubbles in 1 minute, and there wasn't even enough time in the experiment for it to dissolve. But we can rank it number 10 because at least it gave off some bubbles, unlike copper, silver, gold and platinum. Let's take this data back to our reactivity series. So, here's our new order of reactivity, continuing from calcium. Magnesium, aluminium, zinc, iron, tin, and then lead. So, all of these metals reacted readily with acid in a reasonable timescale. However, we're left with these 4 metals over here. And these 4 metals don't really react that quickly with acid. Copper and silver will react with acid, albeit incredibly slowly. And gold and platinum will not react with acid at all. Based on these observations, we can say that copper is the 11th most reactive, then silver, then gold, then platinum. An easy way to remember this order of the least reactive metals is that they get less reactive the more valuable they are. Platinum being the most valuable, gold being the second most valuable, silver being the third most, and copper even less so. So, we've now got to a point where we can build our reactivity series. Potassium, definitely our most reactive of the metals we looked at, exploding with a purple flame when reacting it with water. Sodium, giving off that yellow flame, no explosion, but a reasonably fast rate of effervescence of hydrogen gas. Lithium, effervescence of hydrogen gas, albeit slower than sodium and potassium. And then calcium, quite a slow rate of effervescence of hydrogen gas when reacted with water. These first 4 metals, remember, are the ones that react readily with water at room temperature. The next set was as follows: magnesium, aluminium, zinc, iron, tin, and then lead. Now remember, these metals could be reacted with steam, but it was difficult to make any comparisons. So instead we compared them by reacting them with acid, and we counted the number of bubbles given off in 1 minute, or we timed how long it took for them to dissolve. The more bubbles given off, or the more quickly it dissolves, the more reactive it was. Hence the reason magnesium was ranked above the others. Finally, we had copper, silver, gold, and then platinum. Copper and silver reacted extremely slowly with acid, and gold and platinum didn't react at all. So here was our order of reactivity for those final four. To finish off, what I'd like you to do is read the questions shown on this page, pause the video, have a go at them, and then come back to check your answers. 1. In which group of the periodic table would you find the alkali metals? Group 1. 2. Complete the equations for the reactions of alkali metals with water. A. Lithium plus water makes lithium hydroxide plus hydrogen gas. B. Sodium plus water makes sodium hydroxide plus hydrogen gas. C. To make potassium hydroxide and hydrogen, you would need to react potassium with water. 3. Complete the symbol equations for the reactions of alkali metals with water. A. We've got to react lithium with something here, and it was water, H2O. This would make dissolved lithium hydroxide, that's aqueous to mean it's dissolved in water, and the gas that was formed was hydrogen, which has the formula H2. In order to make NaOH or sodium hydroxide, we need to react solid sodium, Na. The gas formed again is hydrogen gas. This is KOH, so potassium hydroxide. So we're going to need to react potassium with water. We're going to need to add state symbols here and make sure we balance. So, following the trend, 2 potassium, both solid, reacting with 2 H2O, which is a liquid, forms potassium hydroxide plus hydrogen gas. 4. Which gas is made when an alkali metal reacts with water? Well, the gas we can see in all of these equations is hydrogen gas, H2. What part of the product makes the solution alkaline? You'll notice in the product, that means after the arrow of all of the equations, you'll see hydroxide, hydroxide, and hydroxide, and in the formulae you have this OH part here. If you ever see hydroxide in the name of a compound, or OH in its formula, then you're looking at something that's an alkali. So, the part of the product which makes the solution alkaline is hydroxide, or OH. Here's your next set of questions. Please pause the video, attempt, and then come back for the answers. 6. Describe the observations for lithium, sodium, and potassium reacting with water. All of them float on the surface as they dissolve. Potassium was the most reactive, and it effervesced the fastest, and it exploded with a purple flame. Sodium is the next most reactive, effervescing a little bit slower than potassium, and it burned with a yellow flame whilst melting into a ball. Lithium is the least reactive of the three, so it effervesces slower with no flames or an explosion. 7. Describe the trend in reactivity going down group 1, the alkali metals. Reactivity increases down group 1, the alkali metals. 8. Calcium also reacts with water, but more slowly. Explain why it sinks. We can say that calcium is more dense than water, therefore it's able to sink in water. 9. Write a word equation for the reaction of calcium with water. Calcium plus water will make calcium hydroxide plus hydrogen gas. 10. Complete the paragraph. The most reactive metals, potassium, let's go in order here, sodium, lithium and calcium, all react readily with water at room temperature. Here's your next set of questions. Please pause the video, attempt and then come back. 11. Complete the paragraph. Metals less reactive than calcium can be reacted with steam. However, it's difficult to compare their reactivities because the steam obscures our view of the reaction. Therefore, instead, we react them with acid. Let's write a method now for comparing the reactivity of different metals using acid. We're going to place our test tubes into a test tube rack. We're going to fill each test tube with an equal volume of hydrochloric acid using a measuring cylinder. We're then going to use a balance to weigh an equal mass of each metal being tested, making sure we either use all lumps or all powders because we don't want to change the surface area, key control variable. We're going to drop each metal into a test tube at the same time, and then we're either going to time how long it takes for each metal to dissolve, if they will dissolve in a reasonable timescale, Or we're going to compare the rate of effervescence of hydrogen gas by attempting to count the number of bubbles in a fixed timescale, for example 1 minute. Have a look at the next set of questions, and this is your final set of questions. Have a go, and then come back to the video. We've now got to state the independent, dependent and control variables for the experiment that we just described. An independent variable is the thing that you change. A dependent variable is the one that you've measured. And a control variable, there might be multiple ones of these, are the things that you keep the same. In this experiment, the independent variable, what we're changing, is the type of metal, because that's ultimately what we're trying to compare. The dependent variable, what we've measured, was either, depending on the experiment that you did, how long it takes or time for the metal to dissolve, or the number of bubbles given off in 1 minute. It's important to keep the timescale for counting that number of bubbles the same for each metal. Control variables. We used a balance to make sure that the mass of metal was the same. We also needed to make sure the volume of acid that we dropped the metals into was the same, and that the concentration of that acid was the same each time. We'd also want to keep the temperature at which the experiment is conducted the same, and I don't think I've written it here, but remember to keep the surface area of those pieces of metal exactly the same as well. The metals that react extremely slowly with an acid or not at all are copper, silver, gold and platinum. Copper and silver reacting extremely slowly, and gold and platinum reacting not at all. The reactivity series, in order of most reactive to least reactive, is as follows: potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper, silver, gold and platinum.